So another type of searching in data structure is specifically in an array is binary searching. So when we say binary searching, for a binary search to work, it is mandatory for the target array to be sorted. So it means that when we are going to deal with binary searching, all the elements within an array or within the list must be sorted. So binary search looks for a particular item by comparing the middlemost item of the collection. If a match occurs, then the index of the item is returned. So that means here, we're not going to deal with the first position, then followed by the next position like the sequential. So we need to get first the first position and the last position. Then if the first position is less than or equals to the last position, we get the middle element or the middle most item of the collection. So in that case, we are going to compare the target not on the first element, but instead we're going to compare it on the middle element. So if the middle item or the middle element is greater than the item, then the item is searched in the sub-array to the left of the middle item. Otherwise, the item is searched for in the sub-array to the right of the middle item. So in this case, if your target if the middle element is less than your target, that means we're going to look at the lower half. Lower half means the left of the middle item. But if your target element is less than the middle element, that means we are looking for the upper. Okay, so that means it means that the target value is greater than the middle element. It means that we're going to look at the upper half. But if the target value or if the middle element is greater than the target value, we're going to look at the lower half. Lower half means the left of the middle item, and the upper half means the right of the middle item. So let's have an example of that binary search example. So in this case, for example, our target is 22. So as we all know, here in the array list, we get 22 here at position 6. But how are we going to do that? So again, as mentioned a while ago, the algorithm in getting the binary searching is we need to get the first element and the last element. If the first element is less than or equals to the last element, then get the middle element. So how are we going to get the middle element? Getting the middle element is equals to the first position, which is 0, plus the last position, which is 11. So 0 plus 11, that's equals to 11. Then you divide it by 2. 11 divided by 2, it will not be 5 point something. So take note that we are going to truncate the value when we compute the quotient. Okay, we are going to get only the whole number part. Okay, so if we have 0 plus 11 divided by 2, that means the middle element is position 5. So at position 5 is 21. We're going to compare the value in the middle element to our target value. So in this case, target value is 22, and 22, which is the target value, is greater than the element in the middle element. So what will happen? We're not going to already, we are going to omit the lower half. We're going to focus on the upper half because, again, the target value is greater than the middle element. So that means the target element is on the right items or on the upper half. So again, we're going to repeat the process or the execution by getting the first, the mid, and the last. So how are we going now to get the first? So since we already omitted the first, lower half of the list in an array, we're going to change the value of the first. So we're going to point our first to the position when we stop the value of getting the mid. So again, how are we going to get the first? If we are going to take a look at this one, we are going to get the upper half. So the last will not be changed, but we're going to change the position of the first. So in changing the position of the first will be equal to mid plus 1. So mid means middle element is at position 5. Add by 1, it becomes 6. So that's why on the second iteration here, we have the first, which is 6, and then we have the last, which is 11. Then how to get the mid, which is 8? Again, in getting the middle element, you need to test first if the first position is position 6 is less than the last position, which is 11. So if that is true, then you add the first and last to get the mid divided by 2. So this is 6 plus 11, that's 17. 17 divided by 2, just get the whole number part, which is 8. So again, 62 is the element at position 8. So we're going to compare again the value. So the target value is 22. So we all know that 22 now is less than the value at the middle element, which is 62. So in this case, we're going to look at the lower half or the left items in position 8, which is the element 62. And these are 22 and 36. Now, again, we're not going to change here the first, but we're going to move the last here in 7. So how are we going to get that? So if the first element is changed, we change it earlier to mid plus 1. If that is last, if we're going to change the position of last will be equals to mid minus 1. Mid is 8 minus 1, and that is 7 at position 7. So we're going to point the last to position 7. Okay, so the third iteration will be here. So the third iteration, the first position is still 6. The last position has been changed to mid minus 1, which is 7. Then again, we test the condition if the first element, or if the first position is less than the last position. If that is true, then get the mid. To get the mid again, you add 6 plus 7, which is 13 divided by 2. Again, get only the whole number part, which is 6. So 6 is here. So it means that the first is pointed to the address of position 6 as well as the mid. Okay, now, here is the mid. We compare again the target value. So the target value is 22 and the middle element at position 6 is also 22. That means that's already equal. So we're going to stop and terminate the looping value because we already get the index where we can find target 22. So the last function terminates at first, which is position 8. Okay. Mid is 6 and the last is 7. By the way, this is not 8, this is 6. So it should be, first will be the 6. So that's the last iteration. Mid is also 6. And then last is 7. Now, what if the target that we are going to look for is not within the list or not within the elements of the array? So here, for example, our target is 11. So the same thing as what we did from the previous, we're going to get the first position, which is 0, and the last position, which is 11. So in an algorithm, how are we going to get the last position? You just simply get last is equals to the size of the array minus 1, and that will be the last position. So again, we're going to test if 0 is less than or equals to the last. If it's true, then get the middle element. Then again, when we get the middle element, we compare the middle element to the target value. If the target value is less than to the middle element, then we're going to look for it on the lower half. Okay, so lower half are those elements below position 5 or below index 5, which is 14, 10, 8, 7, and 4. So again, since we're talking about the lower half, we are going to change the position of the last element, but not the first, because first has been already pointed to the first position, which is 0. But in this case, since we are going to get the lower half, we need to change the last position. So again, getting the last position is just simply mid minus 1, which is the former or the previous middle position is 5 minus 1, so it becomes 4. So again, we're going to test the first. If the first position is less than or equals to the last, if it's true, then we can get already the middle element. So 0 plus 4 is 4 divided by 2. That's 2. So the middle element is 8. Now again, comparing the value or the element in position 2 in 11, 11 is greater than 8. So that means we are going to omit the lower half, which is the 4 and the 7, and we are going to get the upper half, which is the 10 and the 4. So in this case, if we're going to get the upper half, we're going to change now this time the first value or the position of the first. So how are we going to change the position of the first again? First equals mid plus 1. Okay, so that means the first is pointed at position 3. Also, our last is at position 4, the same thing as from the previous simulation. Then again, to get the mid, you need to test first if the first position is less than or equals to the last position. If that is the case, if that is true, then add. 3 plus 4 is 7. And then you would divide it by 2, so that becomes 3. So the middle element is at position 3, and that is 10. So again, compare the value. If 11 is equals to the value at position 3. In this case, 11 is still greater than 10. So in this case, again, we're going to look at the upper half, but take note that the upper half here, so remember that this gray portion has been already omitted, so we only have the 14. So we still need to stop the execute of, we need to still continue the looping process until we reach the last position. If the last position is not yet the target value, then we can already stop the execution of the loop. So again, we still have one more. So we need to process again the first, the mid, and the last. So since we're going to get the upper half, that means we're going to change the value of the first. So first means mid plus 1. So first will be pointed to position 4. Okay, and then last is also pointed in position 4. So that means 4 plus 4 is 4 less than or equals to 4. If first is less than or equals to last, that's true, then get the middle. Middle means 4 plus 4 divided by 2, so that's also equals to 4. So if you're going to take a look at this one, first is pointed to position 4, mid also, and last as well is pointed to position 4. Since this is the last element, we're going to test this element if it's still equal to the target. But if it's not equal to the target, then we stop the execution of the loop. So that means when we terminate the function, the last first that we encounter is at position 4. The last index that we encounter in the last position is 3. And the last index that we encountered from the mid is 4. Okay. As from the example, this is actually the algorithm of the binary searching. So we initialize the value of the first to 0, then last is equals to end. As mentioned a while ago, last is equals to size minus 1. Then we are going to make use of a loop, and we are going to test if the first position is less than or equals to the last position. If that is true, we get the mid element. To get the middle element, we are going to compute for the first plus last divided by 2. So if the middle element is greater, if the target is greater than the middle element, we're going to look in the upper half or the right portion. So in that case, if we're going to get the right portion and omit the lower half, we need to change the value of the first by changing it to mid plus 1. Otherwise, if it's false, then we are going to have another condition to test if the target is less than the elements of the middle element of the list. So in that case, we're going to look in the lower half and omit the upper half. So by looking at the lower half, we're going to change the position of the last. So how are we going to change the position of the last? By changing it to mid minus 1. Otherwise, if it's true, that means we already find the address where we can get the target. We need to have the force exit. So how are we going to do that? Force exit means we're going to change the value of the first two, last plus 1, to stop and execute the execution of the loop. So you can also use a break for this particular portion. Then at line 5 here, we are again assigned the middle element to another variable here, which is lock n. Then test it again. If the target is equals to the middle element, then it means that we found the element. Otherwise, if it's not equal, from the second example, we reaches already the last element within the list, although it's a binary searching. So that means found equals false, and found equals false means that we do not found, or we did not find the elements within the list.